Hello friends, I hope you all are well. In the last lecture, we have studied about the conductors and the substrates that are used in the thick film technologies. In today's video, we will study about the dielectrics and the resistors that are also used in the thick film technologies. But before moving forward, I request you all to subscribe the channel and press the bell icon to get the notifications in the future. So let's start our today's topic, the dielectrics and the resistors used in the thick film resistors, thick film technology. So let's understand what do you mean by the dielectrics. A dielectric, it is an insulating material, or you can say it is a poor conductor of electric current. Why? Because when you place the dielectrics in electric field, practically no current flows. Because unlike the metals, they don't have a loose bound, or you can say a free electrons from which the electric current can flow. So in Vlsi design, these dielectrics are used in three places. One is crossover insulators for multi-layer conductors. Second one is capacitor dielectrics, and the third one is encapsulation glaze. Now let's talk about the various requirements that are used for dielectric, so that the dielectric has to fulfill to be the best dielectric that are used in the thick film technologies. So now let's talk about the various requirements that a good dielectric has to fulfill. So number one is its breakdown strength should be 250 volt per mils. So 1 mil is equal to 10 is to power minus 3 inch. This is a measurement. Second one is its isolation resistance should be greater than 10 is to power 10 ohms. The next one is for crossover dielectric constant, it should be 6 to 10, and for capacitors, it should be between 10 to 2000 the values. Fourth one is it should have the minimum tendency to form pinholes. Now, what are pinholes? Pinholes are the small craters, or you can say tiny holes. So fifth one is it should have good screening properties. The last one is it should have high resistance to thermal shock. But all these properties can drastically change when they are near to Curie temperature. Now what does Curie temperature means? Curie temperature means the temperature at which various magnetic materials undergo a sharp change. They change their properties. So this is the Curie temperature. So this was the following requirements that a good dielectric has to fulfill. So now let's move on to the next topic, which is the formulations and the materials that are used in making this dielectrics. So in this, there are certain crystalline glass formulations which are used as a binders, vehicles for dielectric paste, which is a similar to that of a conductor paste, but in this it consists of mainly of organic solvents like methanol, ether, etc. So the materials are of two types. One is high and second one is low. So let's talk about first one, the high dielectric constant material. In this, it mainly consists of ferroelectric, ceramic, barium titanate materials, which has a dielectric constant of 1200 at room temperature. But this value can also be affected by the addition of strontium, calcium, and tin. And because of the addition of these three, or any of these three, it also affects the temperature coefficient of capacitance at reasonable values. So this was the high dielectric constant materials. Now let's talk about the second type, that is low dielectric constant materials. So now let's talk about the second type, that is low dielectric constant materials. It consists of several ferroelectric dielectric materials which is of low permeability, which consist of magnesium titanate, zinc titanate and titanium oxide, which has a dielectric constant range from 12 to 160 with temperature coefficient of plus minus 220 ppm per degree Celsius. So it's not 220, it's 200 degree 200 plus minus 200 ppm per degree Celsius. So this was the second type of low of dielectric materials. With this I finish the dielectrics which are used in the thick film resistors. Now we will move up to the our last topic, which is the resistors that are used in the thick film technologies. So now let's talk about the resistors which have to be used in the thick film technologies. So for that, it should fulfill some requirements, like it should have wide range of values. Second one is it should be compatible with the substrates and termination conductor materials. It should also have low temperature coefficient and low voltage coefficient. There should be a good tracking between various type of resistors. Fifth one is it should have low electrical noise. And last one is there should be a good, it should be remain stable in high humidity conditions. So the resistor paste also contain the same three ingredients like in the conductor paste, but in this it consists of some active elements which have low electrical conductivity, which are often based on the oxides of ruthenium. In addition to oxide ruthenium, we can also use the oxides of iridium and osmisium. Also, the sheets which are made or can go down to 1 ohm per square down, and it can go up to 10 to per 9 ohm per square for a 25 micrometer thick resistors. Okay, so we can also obtain the termination of resistors by printing a conductor underneath or on the top of the resistors, as you can see on your screen the image of a pic. And also besides these properties, besides these requirements, you can also see a table which contains some more typical properties. So this was all about the dielectrics and the resistors which are used in the thick film technology. So I hope you understand the today's topic. So I will see you in the next video. Till then, thank you very much.